And so with that, I think I'm going to conclude my opening remark, and I'm going to introduce our first speaker for today. And so I'm very pleased to introduce Ed Olson as one of our own faculty. So Dr. Ed Olson is the co-founder and CEO of May Mobility, another Michigan-based startup company that is transforming cities using self-driving shuttles. We actually work with Ed at company May Mobility for one of our current USDOT ADS demonstration project in Detroit. So May Mobility uses its industry-leading autonomy technology to deploy autonomous vehicles in cities and rural environments in the US and Japan, helping to create a safer, greener, and more accessible world. Dr. Ed Olson earned his PhD from MIT in 2008 in computer science and electrical engineering, and he's currently on leave from University of Michigan, where he is a professor in computer science. Ed?
Thank you. And because I did not follow directions, I have to switch laptops. All right, and switching to the handheld audio guy. Oh yeah, you can hear me. All right, terrific. So I'm Ed, I'm founder CEO of May Mobility. The plan here is for us to do questions at the end. So that is the most fun part for me, where you guys can ask spicy, interesting, challenging questions. The more interesting they are, the better. So keep those in mind. So I wanted to talk today about two things that I got completely wrong about autonomous vehicles and sort of how I've learned through this process. The first one has to do with sort of a technical misconception I had, and the second one has is more on the business side, something I didn't understand about building a business around AVs. So we'll have a little bit of fun as we do this. So before we dive in, a little bit about my background. I've been doing autonomous cars for a long time. I was lucky enough to be at MIT during the DARPA Urban Challenge days. This is our vehicle, a Land Rover LR3. It had a ridiculous array of sensors. It had like 14 LiDARs and 14 radars and a big Velodyne on the roof, and the entire back was racks of computers. So it was a lot of fun. This is me on the big day making a ill-advised last-minute change to the software without any ability to test it. As it turns out, the software worked, but it was still a really bad idea. After graduating, I came to the University of Michigan. I did a bunch of fun stuff here, also robotics. Probably best known for like the Magic Robotics competition, where we built a team of 14 robots. Think of these as search and rescue robots. You send them out into an environment, they build a map, they're working with human first responders to find people who need help. Out of this came these little QR tag type things. They're called April tags, named after my lab. These have actually probably what I'm best known for. They've been on Mars. This is Perseverance rover. I did not have anything to do with the rover, but they used my tags, which was pretty cool. And if you have kids that are in First Robotics Challenge, yeah, they probably have used April tags too. And for that, I am sorry. They work pretty well. After being at the university for a while, I got a little antsy and wanted to get back into autonomous vehicles. So we started the MIT Ford Alliance, the University of Michigan Ford Alliance. As part of that alliance, we had a very large research program to develop autonomous vehicles. This is part of our team here. I did that for about 4 years as a principal investigator, and then went on leave for the first time, where Toyota brought me on to help build their autonomous driving team. So a lot of fun there, but ultimately I got the itch to figure out how to make the business work, and I spun out May Mobility in 2017. So we'll talk more about that later, but let's jump into the fun stuff. All right, part one, technology confession. What did I get wrong? So by the way, I was told here no equations, so there's going to be no equations, for better or for worse. So this is about as close as we get to an equation. This, for me, is really the success story of the last 30 years of computer science, machine learning. The idea that you could go out, you collect a bunch of data, some learning happens, and out comes a model at the other end. It's amazing. We use this all the time, whether it's for reading characters, optical character recognition, or machine translation. We all use this every day. It's really fantastic. And what we've learned is that it's so good that we can solve increasingly hard problems. We can go from tic-tac-toe to chess to Go. And it's just a matter of increasing the data and the model size. This figure's not quite right. It'll just adjust. There we go. So more data, bigger model. And this approach has really helped us over and over and over again. Of course, we rebranded it to AI somewhere along the way. That was a joke. Tough crowds morning. So I think really the idea here is why do some problems need more data than others? And you can think about this as essentially a problem of filling space. So you think about a problem as having some space that you need to explore. If it's a chess, if you're playing chess, it's all the different configurations of a chessboard. The more configurations there are, the more examples you need in order to learn something right. Tic-tac-toe is an easier problem than chess because there are fewer board positions. Now, what we've learned is that autonomous driving is a really, really hard problem. It's a continuous world. It's not just discrete positions on a chessboard. It's continuous values. There's people out there. We don't know what they're going to do. We can't always see them. Sometimes they're around a corner. Sometimes they have intentions that aren't what we want to do. Sometimes they behave adversarially. Sometimes the traffic light changes color on us when we're in the middle of trying to figure out another problem. It's just an endless sequence of weird, strange events. And this is really the misconception that I started off with, that's no problem. What has worked over and over again is go get more data, build a bigger model. Eventually, we'll get enough points in all of this that we'll be able to learn a model, and it'll be able to handle all of these situations. So one of the key ideas that really makes this possible is the idea of self-play. Give me a hands or a thumbs up if you know what I'm talking about. Okay, a couple people. All right, so here's the problem. Imagine you want to build a chess AI. And you go out and you get all of the latest chess games, and people write down chess games. There's thousands, I don't know, tens of thousands of chess games. What's the problem with that data set? They're all people who really know how to play chess, playing chess against each other. So the actual diversity in that data set is pretty bad. And so it's really hard to learn a good chess agent by looking at lists of real-world chess games because they're just not exploring common situations. In fact, it used to be a pretty easy way to confuse a chess AI would be to make a couple erratic moves right away, and then it doesn't know what's going on, right? It's off into an area where it has very little training data, and its performance tends to be lower. So how do you solve this problem? Well, this is where the idea of self-play comes along. The idea that you just have the chess program play against itself, and you can play millions, billions of games, explore all kinds of strange corners and weird board configurations. And this is a great way to generate more and more data, which is a way to build bigger and bigger models. And so the misconception I had was that more data, we could provide it through self-play, have a bunch of vehicles driving around in a simulator, use a data center, lots of power bills, big GPUs, and out would come out the other side the perfect AI. So yeah, forgive the synthetic images here. I was told no equation, so I had to do something geeky. But the idea is that you go off to your data center and you have it play against itself, run simulations, explore all the weird things that could happen. The data center sits there, it burns a lot of energy, and then it spits out your autonomous driving stack. And this one super amazing thing is ready to go and solve all of the world's problems. And what we've learned is that it still doesn't work. Driving is just so complicated. There's so many situations. How many of you drove in today? How many of you saw something weird as you were driving in today? Yeah, probably most of you. The reality is that you think about all the different situations that you can be in, and the situation that you thought even if those people, you can change a situation just a little bit and it becomes a totally different situation. So a simple example, how brittle is autonomous driving in terms of decision making? What you'd like is that small changes to the world do not change what the right answer is. That would be a good, well-behaved problem. For that, you wouldn't need so much data. You could get by with less data. Okay, so here you are, you're an autonomous car, you're approaching a red light, a traffic light, it's green, you're going up to it, the traffic light turns red, what do? Right? It's already kind of like, well, how close are you? Maybe there's a rule in here. But let's suppose, like, it's pretty comfortable, so you decide to stop, right? It's a good time to stop. Okay, no problem. Every autonomous car is going to get that right, hopefully. Now, same situation, we add a car right behind us. We're going towards the green light, light turns red, this guy's right behind me, what's the right thing to do? Keep going, right? If I brake firmly, I'm going to get rear-ended. So we changed one thing in the world, it flipped the answer back to the exact opposite. That's an example of brittleness in the system. All right, same situation, going towards a green light, there's a guy right behind me, light turns red, pedestrian starts walking across the intersection on the other side of the street. What's the right thing to do? We just flipped again, now you stop again. And you're willing to be rear-ended because being rear-ended is a lower risk than hitting a pedestrian. So again, you see how even very, very small changes to what the world looks like radically change the answer of what the autonomous vehicle should do. And this is why autonomous driving is so difficult. We've got companies that have spent tens of billions of dollars in chasing this idea that with enough simulation, enough data, they're going to be able to train the one big AI that's going to be able to handle every situation. And it still doesn't work. This was my mistake too. So I'm going to ask a what-if question. What if you could put a data center on your car? This is more subtle than you think, because what we actually want to do is we want to change the problem that we're solving. So this big spheroid, the super AI thing, the idea here is that you're building an AI that can solve any situation that the car happens to be in. Well, if you're actually an autonomous vehicle, which situation do you actually care about? The one that you're in. Do you care about the situation that you're not in? Well, not at that moment. So what if you could put the data center on your car and build a machine learning and AI system that learns how to solve the situation that the vehicle is actually in? Now, there's a huge amount of leverage in here. This is a simpler problem, right? It's analogous to solving the problem of creating a book that tells you for every chess position, what's your next play. Really hard problem. Versus walking up to a chessboard in a park where the pieces are in a specific position and asking, what is the next best turn? One of those problems, the second one, is a whole lot easier than the first problem. So that would be really interesting if you could change the problem to what's solving the situation that the vehicle is actually in. But to do that, you'd have to have all of your machine learning capability in the back of the car. And nobody's been able to figure out how to make machine learning algorithms, AI algorithms, learn fast enough to be able to solve that problem in the 100 milliseconds or 200 milliseconds that you have in autonomous driving. So that's the trade-off. If you can do the learning on the vehicle, you can solve a smaller problem, but you have to do it incredibly fast, hundreds of milliseconds. And this is a challenge that nobody's been able to do. So here's the idea, bring our data center with us. So this is where we had a clever idea. And it's an algorithm called multi-policy decision making. And this is a form of online reinforcement learning. Reinforcement learning, give me a little pulse check. Who knows what I'm talking about? All right, very good. So here's the idea. The idea is that you're going to imagine different things that could happen. And you're going to have a reward function which tells you whether this is a good thing or a bad thing. And if you get enough feedback, enough positive and negative feedback, you can use this to drive a learning process. And so multi-policy decision making is an online reinforcement learning algorithm. Online in the sense it's designed to run really fast, run on the problem that the vehicle is actually experiencing. This is actually something we developed for that magic robotics competition that I started off talking about a little bit before. And this is where I usually switch to math, but AI to the rescue. This is what multi-policy decision making looks like. Instead of one really, really big super policy, we're going to learn a whole bunch of little tiny policies. We're still going to use the data center. We're still going to collect data. We're still going to do offline simulation. All of that's super valuable. We're not throwing that out. We're not throwing the baby out with the bathwater. This is great stuff. But what we're going to do is we're going to bring along a whole set of different driving strategies. Some of these are, you can imagine, they're conservative drivers. Some of them are aggressive. Some of them like to take the scenic route. So others are like the freeway. And so you've got a whole mix of different driving strategies, just like you could have different styles of chess play. And now the challenge is, can we figure out which of these policies should be in charge at any given moment in time? So it's a fundamentally easier problem once again. Not only are we constraining ourselves to only care about the situation that the vehicle is actually in, now we're saying we're going to start off with a set of about a dozen, maybe 24 policies that are all individually good, and we're going to just fine-tune them and pick one of them the best winner. So we're going to use the idea of self-play. These are going to run a tournament against each other, and they're going to compete for control of the vehicle. And this happens very, very fast. So in about 200 milliseconds, all of this happens. And then that policy that comes out of this learning process runs the vehicle for the next 200 milliseconds. And then what do? We throw that policy away. That situation with the pedestrian that was over there and the bicycle over there, that's probably never going to happen again. We're done with that one. What do? Well, now the pedestrian's over here, and there's a bicycle over here, and the traffic light's turning green. So we have a new problem. So we run the whole process again, pick a new policy, optimize it, learn really fast, running thousands of these Monte Carlo simulations with the self-play, and out pops the new best strategy for the next 200 milliseconds. So about 5 times a second, this vehicle is learning a new policy of how to drive in the situation that the vehicle is actually in. Nobody's been able to make this work except for May. And this is one of the reasons that I think May has been able to do so much with a smaller team, less capital, and be able to go from city to city, because for us, every situation can be unique. It's fine, because we're learning in situ. That's a really huge advantage. So I want to give you an example of what our vehicle looks like and where we operate. How many of you followed May Mobility since early days, like 2017? Yeah, so forget everything you know about May Mobility. So unapologetically, our strategy was always to do what we could do and to commercialize what we could do at every quarter. And early on in the days, we had these cute little electric vehicles. They operated about 15 miles an hour on a good day. They were a little jerky and a little rough, but they were proving out the basic ideas of MPDM and actually earning revenue, which was great. Today, fast forward, we are operating in downtown urban environments. Let me show you. This is actually starting from Tie Spoon off Ellsworth, headed north on Stone School. So let me hit play here. So here we are. We're pulling out of Tie Spoon. Pretty good pad thai there if you like pad thai. Now we're headed north on Stone School. That's Ellsworth. And you can see our vehicle driving along. We're doing 30 miles an hour. Starts off relatively easy, not a lot of traffic. But we're operating at speed, public roads, mixed traffic. We handle pedestrians. We handle people who run traffic lights. We handle people when they roll through stop signs. That was a pickup drop-off stop. So we work with the city to coordinate on where we can pick up and where we can use curb space. This is sped up, so we're not driving at 240 miles an hour. No worries. And now we're getting into slightly more a dense area. And as this is running, just imagine that what's going on is the vehicle every 200 milliseconds is taking the set of policies that we learned offline, fine-tuning them, running these tournaments through self-play to identify which policy is the best. Every 200 milliseconds, we're changing our driving strategy, picking a different strategy that's best suited to where we are. So now we're getting into more traffic. You can see the vehicle tracking, and right now, even right now, the vehicle is having these elections, competing, having this self-play, but of course, when there's cars all around you, basically all the policies agree that maybe you shouldn't do anything. Driving along, and everybody recognized this place, off to the big house. So our operating area here includes a stadium up to about 35 miles per hour. Why don't we operate on freeways? We don't operate on freeways. Any guesses why? Yeah, it's actually not harder. Freeways are incredibly well structured. People behave. There's no pedestrians. There's a big divider. Your closing rates actually tend to be lower than in municipal traffic, where you have head-on traffic moving in the opposite direction. The big problem with freeways is bill of materials. So if you want to be able to operate on freeway, you have to be able to see farther just to have reaction time, and those sensors are really expensive. And so that messes up the unit economics. All right. So that was confession number one, that I thought that more data was just going to solve the problem, and I don't think that's right. I think the key to building an autonomous vehicle system that can actually work is to be able to move away from the offline learning, the learning that goes on in the data center, and bring a strategically very smart amount of the learning in situ, so the vehicle can figure out new situations. It's the only way to really deal with edge cases. All right, part two, second confession. I didn't know how to build a business around AVs. I had a bunch of ideas. Here's idea number one. Well, hey, let's build personally owned vehicles. Let's make everybody's car autonomous. This would be great. Well, no. There's a lot of problems with this. One is that it increased the cost of every vehicle quite significantly, at least in the near term. And then you've got these assets which are sitting around in parking lots all the time. Most personally owned vehicles have an asset utilization under 10%. That is an incredible waste of an expensive machine, a highly capable machine, to be a personally owned vehicle that can drive itself sitting in a parking lot. So two big problems. One is the economics of it. The second one is that we're still going to be parking our cars downtown. That's a drag. Anybody know what these little red things in Detroit? Parking. Yeah, about 31% of Detroit, and actually similar for Ann Arbor, is parking by area. We waste a huge amount of space just storing personally owned cars that are doing nothing. This is a huge problem. I'll actually come back to this a little bit more. But making autonomous personally owned cars is only going to make this worse. Right? It's going to make it easier. More people are going to want to take their personally owned cars to work instead of taking public transit. It's going to add to the parking drag on cities. And we end up with lovely environments like this. Isn't this what everyone imagined future cities of the future would look like? Concrete asphalt lakes filled with metal boxes that sit around and do nothing. That's not the answer. So yes, we could potentially do that, but that's not what I want to build. All right, so we need a different plan. Here's idea number two. We'll do robo-taxis. This actually solves both of the problems from before. So asset utilization is going to be a lot higher, right? Because as soon as I finish dropping you off, I'm going to go pick up someone else and take them somewhere. So asset utilization, good. You can amortize the cost of that hardware much more effectively. How about parking? Partial credit, right? Like, asset utilization's high, so the vehicle shouldn't be parking, except for one pretty big bug, which is that if you've seen Lyfts and Ubers, oftentimes they're driving around empty. So in a lot of ways, we've just moved the parking from a parking lot to the street. And you've got a moving parking lot, which is in pretty much every possible way worse. Worse for safety, worse, the streets are more expensive on a square foot basis. So having roaming cars waiting for their next ride is also not a great solution. Oh yeah, I had a picture for this. All right. So at this point, I'm trying to figure out how are we going to build a business around autonomous vehicles. The first two ideas don't seem to work very well. I wanted to figure out what are the problems that cities actually have? How can we actually solve them? And a lot of it comes down to buses. So imagine that you're a city transportation planner and you're trying to get people where they want to go. But you're doing it in North America. You had the bad luck of being a city planner in North America where everything is really ridiculously spread out. And no two people are generally going to and from the same location at the same time. So you as a city transportation planner have to figure out how to route a bus so that you can actually put people on the bus, but no route exists because everybody's so spread out and the demand for transportation is so diffuse. So what do? Well, you got to do something. So you end up operating buses that are almost empty. In fact, when we have investors and reporters around, when we do demos here in Ann Arbor, we play the bus game. In the bus game, the rules are really simple. We operate Siennas, so every time we see a bus with less than 5 people on it, we score a point. We always go undefeated, right? Every bus has less than 5 people on it in Ann Arbor. And this is a massive waste. And it's not because transportation planners aren't smart, it's because they've been dealt a terrible hand. A very challenging environment to build public transit in, and oftentimes the wrong tools to deliver that transit. Let's talk about how bad a bus is for those kinds of places. How much does a bus cost? CapEx. A cheap bus is about $500,000. If you want a natural gas or electric bus, $750K to $1 million. Very, very expensive. Actually, that's not even the biggest problem. How much does it cost to operate a bus? How many dollars per hour? Any guesses? Someone brave. $100 more. Not quite 1,000. That would be a great business for us. That'd be It's about $150 an hour if you average nationwide. A little less in smaller cities, a lot more in bigger cities. This is a massive amount of dollars going to operate buses that are primarily empty. And these buses are generally emitting lots of fumes and not providing a lot of service. They take up a lot of space. Generally, not a very good solution for cities. There's another problem, which comes back to the parking. So there's a great book, Strong Towns. Raise your hand if you've read the Strong Towns book. One person, all right. We'll just have a conversation here, just the two of us for a minute. So it's a city transportation planner from Brainerd, Minnesota. I'm from Minnesota, so I'll take credit for him. And the basic idea is to think about every parcel of land in a city as having its own little profit and loss statement. So every parcel of land generates revenue in form of property tax revenues. And so some parcels are better than others. So a parcel filled with a bunch of little restaurants and cool little stores actually generates a lot of property tax revenue. Housing is actually maybe not so much property tax, but it's providing workers and driving the economy and providing consumers that are buying stuff. Also a good use of space. What do you suppose is the worst use of land space? I already gave away the answer. Parking. Yeah, all right, we're waking up here. So not only does parking generate very little revenue, it's actually hugely expensive to put in. Especially if you're talking about a multi-level parking structure, those can run about $20,000 per space in construction costs, or more. More if you're going underground. So they're very expensive, they generate very little property tax revenue. So that's sort of the spectrum of on the income side. What does it look like on the expense side? Well, almost every parcel has roads around it. Those roads need to be repaired. They need to be plowed. There's pipes underneath the road. You need to provide fire service to every parcel of land. And so the cost for a city of supporting almost every parcel is actually pretty similar, regardless of how that parcel is used. And the unfortunate consequence is that if you've got parking, you're underwater. You're losing money. Costs the city more to maintain the infrastructure than that parcel will generate. Other kinds of land use generate a surplus. And this is exactly what led to Detroit's municipal bankruptcy in 2013. You have a city with massive infrastructure expenses because the city is so diffuse, so dilute, so much parking that they did not generate enough property tax revenue to pay for the expenses in infrastructure that needed to support their sprawling city. This is a massive problem. You think Detroit is the only city? No. Basically, every city in North America is on a path of severe financial distress because they are not generating enough property tax for the amount of infrastructure that they need to spend. This is one of the problems that city planners are facing. And so some of us tend to think like, oh, well, you know, it's the US and we have cars and there's nothing we can do about it. It's not actually true. So this is the Delft market plots in the Netherlands. And we think of the Netherlands like, they love public transit. They didn't always. After World War II, they went down the same path the United States did in terms of embracing car ownership, converting large open spaces into parking lots like this. And they decided, no, we don't want to do this, and they changed direction. So the market plots today looks more like this. It's a pedestrian mall where you can walk and cycle around. But the key thing here is not to think that they never went down the path that the United States did or North America did. They absolutely did. The encouraging thing about this is that we can go back. We can go back the other direction and have places like this to live. How many of you during COVID, it's the worst possible reason why we experienced this, but enjoyed the fact that restaurants were spilling out onto the streets? There was more room. You could walk down State Street or Main Street. It was amazing. People would tell me, like, why can't we live like this? We can't live like this because we've got people bringing their personally owned cars downtown every single day, clogging up the streets, making it unsafe for pedestrians. You don't want to let your kids wander around. We did this to ourselves. And we know that providing great public transit comes with a huge number of advantages. One mass transit solution like this, a little tram, equivalent to about 20 lanes of road. The throughput of this guy is about 20 lanes of traffic. And it's not just moving people, it's increasing property value. Who doesn't want to live in a place that has this sort of walkable place where you can walk to go get coffee or the groceries? Most of us do. And this tends to increase property values because the most expensive parcels of land are the ones that are best served by public transit. So this is a future that we could have, except for that tricky personal car ownership thing. So there's a quote that I really love. It's a developed country is not one where the poor have cars. It's where the rich use public transit. And I've got two people here because it's really confusing which of these guys said it first. So I'm spreading my risk. One of these guys said it first. The other guy said it second. These are mayors in Bogota, Colombia. And I think they're exactly right. But I think one thing that a lot of people get wrong about this is that the way to do this, at least in the United States, would be through a regulatory structure. That's just not going to fly in the United States. Go to people and you tell them, we're going to take away your car. You're not going to be able to drive to work. That's not going to go over very well. You need to have a different strategy in the United States to support this kind of transformation that I think we all want. And so putting it together has led to what May Mobility is today. Our vision is to transform cities by providing public transportation that outcompetes personal car ownership. We want to make public transit so good that all of you who do have cars and could choose to drive them say, nah, I prefer to take public transit. I prefer to take a May Mobility vehicle. That is the way to win in the marketplace, to build a better product, one with higher quality service, one with less wait time, that's more convenient, saves you money. That's what May Mobility wants to do to help create cities that we want to live in. And so today, think about how cities might function. Here's sort of a cartoon of a city. You've got kind of a rural area, a suburban area, a downtown area. This, I've drawn in a tram line, and you can see there's stops along here. These little dotted lines kind of represent the areas where people can get to the service area of a tram station. And they're pretty small. In most parts of the United States where you do have public transit, the only way you're getting to public transit is usually by walking. And so people walk about 400 meters and then they give up, or they decide it's inconvenient. And if they're outside that 400-meter radius, what do? They prefer to drive. So we're collecting a very small amount of the transportation demand with these tiny little circles and pushing everyone else, creating an incentive for them to get their own car, whether they can really afford it or not, and drive themselves to work, and then leave their car downtown. So how do we see autonomous vehicles fitting into this? It's more like this. So autonomous vehicles, we do not want autonomous vehicles driving everyone in and dropping them off downtown, because then we've just created the robo-taxi problem of now we've got more cars downtown. So they have to integrate with public transit. The idea here is that if you're in a rural environment, there may not be public transit, or mass transit, I should say, and so the vehicles provide direct point-to-point service. Just take you door to door. In other places, they can increase the basin of attraction for public transit. Get you from your house to the mass transit, and then you go whoop downtown, and then get you to your location at the other end. There's one other difference between these plots. If you like that old game of spot the differences, there's fewer mass transit stops over here. Why would that be a good thing? Nothing more annoying than being on the Green Line in Boston that stops every 200 feet. Right? It really slows down the throughput. It makes people crazy. So part of what we can do by providing better last mile and middle mile kinds of transit options is that we can put the stops farther away, the trains can move faster, and so now we can start to think about competing, a multimodal trip competing with personal car ownership. Because remember, what we're competing with is this guy could just drive his car all the way downtown. He's going to get stuck in traffic, but he's going to be in his own car. There's a lot of advantages to that. We like that as Americans. And our proposal is that we're going to have 3 legs. First, an autonomous vehicle is going to pick you up at home, take you to the stop. Then you're going to take a train ride over here, and then you're going to have to take another mode of transit. That's got to be better than the car ride. And so every single part of this journey has to be ruthlessly optimized for efficiency, convenience, and desirability. And we can do it Because driving, commuting into work sucks, right? It's a terrible experience. This just has to be better, and today it's not. So today, our vehicles, I'm talking a little too long. Our vehicles are Toyota Siennas. This is part of our collaboration with Toyota. Toyota is one of May Mobility's biggest investors. We work with them on the Sienna. This has a FMVSS certified vehicle. There are very few FMVSS vehicles that are legal in all 50 states. This is one of them. It's great for business because we can operate these in all 50 states, and we can have as many of them as we want, which is a big difference from other AV companies. We also really focus on accessibility. We want our vehicles to be wheelchair accessible, so that we have a wheelchair ramp that can be operated here to carry everybody. Usual stuff inside the vehicle. And one of the highlights from 2023 is that May Mobility became the third company in the United States to offer rides to the general public without a safety driver on public roads. So in Sun City, Arizona, this is a really remarkable community. It's a primarily retirement community, so the average age is 76 years old. Over a third of the people have some sort of disability that can impact their mobility. So these are people who have a hard time getting to social events, to Bridge Club, or to the rec center, or to medical appointments, or to the grocery store. This is a place where we can really measurably improve the quality of life of people who live in this city and get people who can't drive or shouldn't be driving off the road other ways. This isn't just good for the residents. One of the benefits that we learned about is that actually this is a huge deal for medical healthcare system. One of the biggest problems they have is that people can't get to their appointments on time. And so you end up with a very inefficient medical scheduling system where they fill up their schedule, but only half the people actually manage to make it to their spot. So there's a huge amount of latent capacity in the healthcare system just due to the fact that transit is so bad that people can't get to their appointments on time. So we're creating value not just for the riders, but also for the healthcare system and the shops that they visit. Now, most of you probably don't know a whole lot about May's commercial operation. Again, we sell primarily to cities, not to consumers, so we're not really a consumer brand. But we've operated in 12 cities, all across the United States and in Japan. There's a lot more than 12 up here too, and most of them say unannounced because our customers like to announce. They like to take the press. But over the next year, expect May Mobility to be popping up all over the United States and many more launches in Japan. And we've done this with some great partnerships. I already talked about Toyota, but NTT led our latest investment round, which brought us to over $300 million of capital raised to date. And we also have a number of insurance companies, State Farm, Tokyo Marine, IOE Insurance. Working really closely with insurance companies is incredibly important. They want to understand what their future business models are going to look like, and we need insurance coverage. So it actually works out really well. One of the things that we've started doing is we have a live API. We're the only AV company that provides live data feed to our partners and customers. Our customers can know the status of our vehicles at the same second that we learn about the status of our vehicles. A vehicle has an intervention, everyone finds out at the same time. And this has turned out to be a really important advantage for us in the wake of the cruise challenges in San Francisco, where there was a real sense that crews may not have been as forthcoming as they should have been. We combat that in part by providing our customers, including our cities, with this live data feed. They see everything. It's all upfront, all available from day one. So I will stop here and would love to take any questions.
Thank you, Dr. Olson. I think we have time for like a couple of questions. So Debbie, if you don't mind going up there.
You've got a question?
Okay, I'll go. Does this work? Okay. You're simulating, the transit, the rail, and the cars driving into the city. Can you comment on just how practical you see under mobility as a service of e-bikes and scooters and other things that could be part of that model?
Yeah, absolutely. So we definitely are not advocating that all public transit should be May vehicles. So we think that we're big believers in the multimodal solution. It's not everybody's going to be able to use a scooter or a bicycle, and so we think that there need to be accessible alternatives available. But in the same way, we don't want to eliminate trains and buses where buses do work. So we view this as like a city transportation planner. They're like Batman, they've got tools on their belt. We view autonomous vehicles as a really good new tool that they can bring to bear. Not the only tool. I think we have a mic back there, but there's a question here. Oh, yeah.
So yeah, thank you so much for the fantastic presentation. It's a little bit of a business-related question. So the VC funding is not as what it used to be for autonomous driving back in 2020, 2021. So I'm wondering, have you done any calculations related to how many rides you need to provide in order to start making money?
Yeah, absolutely. So May Mobility, I'm confident, will be the first AV company to reach profitability. And the way that we do that is that we keep our burn rate very low. So May Mobility is quite small in comparison to a lot of our peer AV companies. So we're about 280 employees. And that's still a lot of people, don't get me wrong. We still invest a lot of capital in building the technology and building our operations. But it's a lot less capital than, say, a Waymo or Cruise, which may be well north of $10 billion. So I think Cruise last year, this was before the tricky bit, I think they spent $900 million over the course of 3 quarters or something like, just ridiculous amounts of money. And the challenge for them is that if you're spending $300 million a quarter, in order for you to reach profitability, you probably need something on the order of 200,000 vehicles deployed. We need about 1,800 vehicles deployed to reach profitability. And so we think that is a much easier, much more achievable thing to do. And that the number is so much lower because we keep our burn rate much lower. Over here, sorry.
Hello. Is this on? Yeah.
Yes.
So Ann Arbor is one of the cities that May works with. 2 questions. Any plans to expand the service area in Ann Arbor? And then can you speak a little bit to May's relationship with city government and or the Ann Arbor Area Transit Authority?
Yeah, so one of the things that I would love for us to expand more in Ann Arbor. The Ann Arbor Transit Agency is not very aggressive on embracing AV. And so that's been a challenge. The reality is that from a pure business case, Ann Arbor wouldn't make any sense for us to operate in at all. This is something that I think there's a huge opportunity. Just looking at playing the bus game, there's a huge need for transportation that's more agile, more accessible. And I think there's an opportunity. It's just finding the right stakeholders to lean in. I think that answers a little bit of the second one, but maybe the meta question is that relationships with cities are also really important. And I think one of the challenges that we've seen in the AV space is that cities and regulators more broadly are oftentimes viewed by AV companies as the people who say no. Right? They're viewed as the barrier. No, you can't operate your vehicles here. No, you can't leave your scooters on the sidewalk. No, you can't use this curb space. And I think that has led to a lot of a tendency towards very adversarial relationships between technology mobility companies and the cities. Key thing to know is to recognize with May Mobility is that our business model completely flips that around. The city is our customer. We don't do anything that the city doesn't want us to do. Where do you want us to provide service? Where do you have a need? Which curb space do you want us to provide? Which communities need wheelchair, a higher proportion of wheelchair accessible vehicles? So it really flips all of that around and turns it into them as being guides, Sherpas through the regulatory and licensing path. And it feels good because I feel like we're doing the right thing, but it's also a really great relationship.
Well, we have to wrap it up because of timing. Thank you so much.
Thank you so much.